my name is James Xu. Today my topic is Data Lake Analytics, Alibaba's Presto experience in cloud. First, some information about myself. I'm a Presto developer at Alibaba Cloud. I have been very interested in big data programming for many years. Have participated in projects like Apache Beam, Apache Storm, and became committers of these two projects. And I have translated an English book called Color Programming into Chinese. The name of our product is Data Lake Analytics. Here is its business architecture. On Alibaba Cloud, users' data, analytic data is mainly stored in OSS due to its scalability and cost-effective charging model. The data in OSS might come from many sources, for example, archived transactional data, logs of users' application, or from users' current data warehouse. Since it's very scalable and cost. About the data lake storage engine layer, we have the data lake computer engine layer, which shows DLA's product family. First, we have one-click data lake solution to sync users' DB data into data lake. And for streaming data, we have Spark Streaming to ingest it. And for metadata, we have metadata management and metadata auto-discovery to make it very easy. And if user need to do some ETL or things like machine learning, we have Service Spark. And if user need to do something like ad hoc query, data exploration, or lightweight ETL, we have Service SQL. Service SQL is based on Presto, and it is the protagonist of today's topic. Let's first talk about why we choose the Presto as the base engine of DLA SQL. There are 4 reasons, I think. First, it is full memory processing engine, so it is blazing fast, avoided any unnecessary I/O overhead, so it is very suitable for things like ad hoc query, data exploration. Second, it supports full SQL semantics, so you do not need to worry that if there is any SQL syntax that it is not supported. And third, it has a very extensible architecture, so users can add its own connectors to connect to users' homemade data sources if necessary. And then last, Presto has a very great community. It is now hosted under the Linux Foundation, and many big companies like Facebook, Alibaba, Twitter, Amazon, Jingdong, Toutiao, all using Presto to do big data analysis. And in DLA, we use Presto like this. This is our full architecture of DLA SQL. There are 3 parts. At the bottom is the Presto clusters. In each Alibaba Cloud region, we have 2 kinds of clusters. The first one is the default cluster. In default cluster, users are charged by the scanned data size. And other clusters, we name it CU cluster, which is purchased by users and charged user by the CPU cores user required. And at the top of the architecture is the front node. Front node have implemented MySQL protocol to let user interact with. It will translate the user's MySQL style SQL statement into Presto style SQL statement. And it also do query routing to route the user's query into the correct cluster. And on the left side is the unified metadata service. It stores all the metadata about, for example, data sources, schema, tables, columns, so our cluster does not need to talk directly to the underlying data source for meta. And to host Presto as a service, there are many challenges. Today I will talk 3 of them: multi-coordinators, multi-tenancy, and the connector optimizations we have done. First, the first one, multi-coordinators. So what's wrong with single coordinator? I think there are 3 reasons. First, if you only have a single coordinator, its load will be very high because the responsibility of a coordinator is too much. It has many responsibilities. For example, query parsing, task monitoring. So its load have high correlation with query count and worker count. And second, if you have only single coordinator, it is the single point of failure in your architecture. Once your single coordinator is down, your full cluster is down, it's unusable. And third, if you only have a single coordinator, then it is impossible to do graceful upgrade, which means when you need to upgrade your cluster, your full service is down. So it is unacceptable for an enterprise Presto service. So it is a must to implement multi-coordinators as a service. But it is not that easy to implement it. There are many challenges. For example, if you have many coordinators, which coordinator should the user connect to? Which coordinator should the worker report to? And also, there are some global decisions to make in a Presto cluster. For example, when your cluster is overwhelmed, to make sure the cluster can proceed continuously, we need to use OM killer to kill some of the query. Who can make the decision if there are many coordinators? So with these challenges in mind, we have designed the following architecture. We have introduced the Zookeeper into the whole arc. Zookeeper will help us to do the coordinator leader election. It will elect one of the coordinator to be the leader, and the rest will become the follower. And for the leader coordinator, it behaves just like a community coordinator. It first starts a discovery service in it, and all workers will report to leader coordinator. And the leader coordinator also responsible for global information gathering and decision making. For example, worker state monitoring and big query killing. And it also execute and monitoring the queries assigned to it. And for the follower coordinator, its responsibility is much lightweight. It fetches worker list from the leader and execute queries, nothing more. So it's very lightweight. And about the coordinators, there are our front node. Our user only connected to front node. So it is fully transparent to users that we have one coordinator or multiple coordinator. And with this architecture, when the cluster grows, we have more queries or we have more workers, we can add more coordinators to distribute the load. So it is extensible, it is scalable. And with this architecture in place, it is very easy to do grace upgrade. We have a dedicated node, we call it admin node to do upgrading. The admin node will first send a shutting down command to the follower coordinator. The follower coordinator will not shut down immediately. It will wait all the queries to complete before real shutdown. And when all the queries is complete, the follower coordinator will go offline for real upgrade. And then now the cluster looks like this. There's one coordinator and all the workers. It is still a working cluster, and the users can still issue queries. And then the follower coordinator will go online again. And now we have multiple coordinators again. And then admin node will do the similar thing to the leader coordinator, just like what had been done to the follower coordinator. One difference is that once the leader coordinator is down, the follower will take over. but the queries will not be affected, since it is just the leadership is changed, but the queries will not be affected. It's not in the control sequence. And the follower coordinator becomes the leader coordinator. And then the leader coordinator is up again and becomes the follower. And then the admin node will do the similar thing to the workers. But one difference is that because there are too many workers, admin node will not upgrade them one by one. Instead, we will upgrade them one batch by one batch. And one consideration is that we need to reserve enough workers online to make sure that the user query have enough resource to execute. And just like how we upgraded coordinator, when we upgrade the worker will wait for all the tasks to complete before real shutdown. So make sure no queries will be affected. So one batch by one batch, all the workers will be upgraded and no queries will be affected. Principle. And the next one I will talk about is multi-tenancy. Why we need multi-tenancy? If you only use Presto in your own company, it is not so important to implement multi-tenancy. But as a cloud service, there are many tenants who will use our service in one cluster. So we need to make sure that one tenant can't operate another tenant's data source. And the one tenant's query shouldn't affect another tenant's query performance. So there are metadata multi-tenancy and computer multi-tenancy we need to achieve. First, metadata multi-tenancy. Here is the architecture of community Presto and the DLA's Presto architecture. One of the big difference between these two architectures is a unified metadata service. In community Presto, all the connectors retrieve metadata information from clusters, catalog, property files. So when user need to add new data sources, user need to add new catalog files and restart the cluster. But in DLA's Presto, we have optimized this to store all the catalogs information in our unified meta service. So when user need to add a new data source, he doesn't need to do any cluster rebooting. He just issue a DDL command like this. And with the help of the unified meta service, it is very easy to do global access control. So we have provided MySQL style grant revoke access control mechanism. This is metadata multi-tenancy. Oh, and also the unified meta service has built-in multi-tenant support. One tenant can't operate other tenants' data source. And also, a user within one tenant can only access the metadata of its own. It has access to. This is metadata multi-tenancy. And the second is computer multi-tenancy. And the community Presto has basic support for resource isolation, which is called a resource group. It claims that it can restrict the CPU memory usage of each resource group. But it has shortcomings. If there are many tenants using the same Presto, and one of the tenants have submitted a very big query into the cluster, and the very big query will generate a lot of splits, and this query will use up all the resources of the cluster, and all other tenants' query will be affected, and no punishment will be put to this tenant. The only punishment is new queries of this tenant will be blocked, but the damage is already done. Other tenant is already affected. So we have designed what we call the multi-tenant resource manager. We have introduced a new module called the resource manager into the architecture. The resource manager will connect all the tenants' resource usage and calculate to see if any tenant have exceeded the resource usage threshold we have defined. If any tenant have exceeded, we will mark the tenant as to be punished. And the resource manager will notify this punishment information to all the workers. And in each worker, there's a scheduler to schedule user's query to run. When the scheduler starts to work, it will first check whether the tenant in question is punished. If it is punished, all its splits will not be scheduled, and to save the CPU resources to other tenants. One difference with the community version is that in community version, there's only one global multi-level priority queue for all the queries. In our design, for each tenant, there's a dedicated multi-level priority queue. So the splits of different tenants are separated. And within each tenant, the scheduling logic is similar like the community Presto. So a short query gets more CPU time and the long query gets less CPU time in each scheduling cycle. And here is a demo, shows how this scheduling logic works. We can see that when the tenant CPU usage is under threshold, the query runs smoothly. Oh, the x-axis is the scheduling cycle, and the y-axis is the CPU threshold. When the CPU usage is under threshold, the query runs smoothly. And when the CPU usage in the fourth cycle, the CPU usage exceeded the threshold, but not too much. Not exceeded twice of the threshold. The tenant will not be punished in the next cycle, but the exceeded amount of CPU will be accumulated to the next cycle. And in the next cycle, the CPU usage exceeded twice of the CPU threshold. So it will be punished in the next cycle. In the next cycle, there's no running, no scheduling for this tenant. It is punished. So CPU resource can be saved for other well-behaved tenants. And in the seventh cycle, because the punishment cycle is over, the tenant's query can run again. And here, some evaluation we have done. The test setup is like this. There are 4 workers, each with 4 cores and 8 gigabytes of memory. And the test data is TPCH 20 gigabyte. And the SQL we used is 20 SQL of TPCH. Its characteristic is that it has joined many tables, so it will use a lot of CPU resource. And the scenario is we used 4 tenants, A, B, C, and D. And for A, B, C tenant, each submit 1 SQL. And for the D tenant, it submits 5 SQL. So we expect that the tenant D should be punished. And on the left is the community version. In the community version, tenant D, the yellow line, used too much split. It's much higher than the average. And on the right is the DLA version. We can see that all the lines have a similar shape, which means computer resource is isolated. And here's another evaluation from another perspective, which is query duration. On the left side, we can see all the queries, all the 8 queries cost a similar time, which means no punishment. even if the D has submitted 5 queries, they end up with the same time with other queries. And on the left is the DLA's version. The query 1, 2, 3, which corresponds to tenant A, B, C, use less time to finish. And the queries 4, 5, 6, 7, 8, which corresponds to tenant D, used much longer time, which means tenant D has been punished. And with this computer multi-tenancy in place, we can safely serve all customers within one Presto cluster. And the next thing I want to talk about is connected optimization. We have added support for many data sources on Alibaba Cloud. For example, Alibaba OSS, which is global store. We support read, write from it, and we have an optimization that can reduce OSS API request down to 1/10 to 1/3 compared to community version. The second one is Alibaba Table Store. Alibaba Table Store is the most extensively used KV store on Alibaba Cloud. With DLA's integration, user can use DLA's SQL statement to analyze KV data stored in Table Store. And the DLA can auto-pick the best secondary index if applicable. And the third is Alibaba Analytic DB. Analytic DB is the most fast OLAP data warehouse solution on Alibaba Cloud. With DLA's help, user can pre-process data before ingested by Analytic DB. And for Alibaba Max Compute, we support read and write from it. And also we support read from Max Compute external table stored on OSS. And we also support all the connectors supported by the community Presto. And we have done many optimizations like parallel read for RDS data sources. And here I will introduce in detail how we have saved a lot of OSS requests. We know that when OLAP engine like Presto communicate with OSS, it uses the Hadoop file system API. And in community version, Alibi in OSS file system will issue a new request in 2 scenarios. The first is if it has read more than 512 kilobytes data, or if there is a seek operation. Okay. So we have optimized in the following way. First, we will read as much data as we can with just one request until there is a seek. But if the seek is very small, for example, only 100 bytes, we will not do a real seek. We will continue reading, but discard the data. It will waste some bandwidth, but worth it. And we continue to read until there is another seek. And this seek is very big. It is 128 megabytes. We will do a real seek. So then we'll start another read. So in this demo, there's another read in the Hadoop file system API, but we only have 2 read requests to the OSS API. So we have to do some test. Here is the diagram comparison. We can reduce the API request count down to 1/10 for data stored in text format, and down to 1/3 for data stored in ORC or Parquet format. So it can, on average, it can save about 60% to 90% cost for user. And these are all I want to share today. And here's more information about the DLA. And also, we're hiring. Thank you.
Thank you so much. And it looks like we do have a connection with James Xu. He's going to be presenting here. Hey, how are you?
I'm good, thank you.
Hey, thanks so much for coming in here. So data lake analytics. Alibaba's Presto experiences. We're very curious to hear more about this.
Yeah, Data Lake Analytics is the data lake solution we provided in Alibaba Cloud. And it's based on Presto, and we have done many optimizations in it. The main storage people use in Alibaba is OSS, which is a blob store service, and people also use, for example, RDS, OTS, or MongoDB, etc.
Okay, the data lake analytics solution for Alibaba Cloud. How big is that? Can you give us some idea about how much data is in there?
I think it's about EB. I don't know how to pronounce it correctly in English.
Enormous. I think that's the correct English. That's the correct English word.
Okay.
Exabytes. You have exabytes of data.
Yeah.
This is very cool. Tell us a bit about yourself and your history while we wait for the presentation to launch.
Okay. I'm a Presto developer at Alibaba Cloud and committer of Apache Beam and Storm, and have done many interesting things in big data programming. And it's about 1:30 a.m. in China, but I'm fully awake to enjoy the great sessions.
Thank you so much for calling in the middle of the night.